Good morning, guys, and welcome to week 3 of term 2. Today, what we are looking at is we are looking at function notation and domain and range. So what we've previously done is we've had simple equations of y equals something or other, and we have just gone along with that. But what we need to start thinking about is functions, because what you're eventually going to have to do is you're going to have to find simpler ways of representing complicated ideas. And so to do that, what we do is we start, instead of saying y, we start saying f of x. And what that means is the function with respect to x is equal to say, for example, x squared. And what I might then do is I might have a different function, similar idea, it's called g of x. And g of x is equal to x squared plus 1. All right, and what I can then do is I can then say, okay, well, what is f of x minus g of x? What is f of x minus g of x? Now, a reminder, that is all of g of x. What might the answer be? Does someone in the chat want to have a go and take a guess at what the answer might be? One. I got some people saying 1. Ali saying -1. Ali, why do you reckon it's -1? Nita also -1. Why do you guys reckon it's -1? If 1 is moved to the other side, it becomes a minus. Because the squares cancel out, you're left with 0 minus 1. All right, so Ali, you are correct. It is in fact -1 because you are subtracting the entirety of x squared plus 1, which means that when you were to write it out, it would be x squared minus x squared minus 1. All right, but what happens if I start doing funky things like, what is f of g of x? F of g of x. What do you think is going to happen? How would you describe what the resulting equation might be? Hawa, you're awfully close, not quite, but I would say you're very close. You've certainly got the right idea in that the powers start to expand. Ali, also, pretty close, pretty close. So what's going to happen is that I will then, so in this function here, f of x is equal to x squared. What have I replaced the x with? I've replaced it in here with g of x, and I know that g of x is all of this. So what I'm going to therefore do is replace the x here with all of this, and I end up with x squared plus 1, which is g of x, inside x squared, like so. And then that's a simple case of x of 4 plus x squared plus x squared plus 1. So it's x to the 4 plus 2x squared plus 1. So Ali, very, very close. You just missed the 2. All right. And the reason why we do this is because sometimes you aren't using y's, sometimes you aren't using x for some reason. So, but you still need a way of consistently representing your equations without necessarily constantly translating things. So what I might have is, okay, d of t is equal to t squared plus 3t minus 3. Find d of 5. On my equation, what have I replaced t with? On the left-hand side, that means I have to replace t with 5 on the right-hand side. So the way we used to do it was, okay, find y when t is 5. But instead now I can just say d bracket 5 equals, and it's a lot less language, a lot less space taken up, makes it much easier to write our equations, gives us more room to work with. So in this case here, d of 5, so we're going to have 5 squared plus 3 times 5 minus 3. 25 plus 15 is 40, minus 3 is 37. Nice work. All right. So this is designed to help us save a lot of time, especially when we come to inverse functions and calculus. Yes, that is the name, WTF. What the function. All right, so eventually what you're going to be doing is you're going to be working towards replacing all of your normal mathematical work, representing it in what we call function notation. So in the textbook, 5A and 5B outline some of the general terms that we might be using. And then 5C is the introduction to it written like what we've got up on the screen here. All right. Now, but there are 2 other words that I really, really, really want to make sure that you guys have down pat. All right. And those words are domain and range. All right. So domain are all the possible values horizontally. And the range are all the possible values vertically. All right. So you might think of domain as all possible values of x, range is all possible values of y. All right, but we're trying to move away from x and y. We'll start thinking about functions. Domain, everything horizontally, everything ranges, everything vertically. All right, and what you're going to get asked is, okay, for my graph here, we'll have a very, very, very poorly freehand drawn circle. Vertical means up and down, horizontal means left and right. All right, so imagine this was, parallel of straight. Yes. So what we've got here is I've got a circle here, very poor circle, but it's still a circle because I says so. Center is at 0, 0. We go all the way up to here at 3, down here to minus 3, 3, and 3. The equation is x squared plus y squared equals 9. But what is my domain and my range? D and R. What possible values of x along the horizontal can I possibly have? What possible values can I have for my domain? You may want to try rewriting it the other way around, because remember we go smallest to largest. So in this case here, the smallest number that we have is minus 3, and the largest number that we have is 3. Now, you can either use square brackets or curved brackets. Square brackets are for when your equation goes up to and including that number. So what you might used to have used is, instead of saying this, you might have said, minus 3 is less than or equal to x, which is less than or equal to 3. So instead of writing it like this, we are now writing it like this. So the domain is all numbers between minus 3 and 3, including those extreme numbers. All right? And our range, coincidentally, happens to be the same, because we have minus 3 down here and 3 up here. All right? Now, what happens is when we move away from these fixed functions and we move towards bigger things. So for example, if I draw up an axis here for you, try and do it properly. And if I were to draw, for example, let's draw f of x squared. All right. What does f of x squared look like? Well, all right. Again, bad drawing, I know, but I hope to make a point. It starts up here, comes all the way down, it touches at 0, 0, and then bounces off and goes the other way at the turning point. What are all the possible values for the domain and for the range? What are all the possible values that the domain can be? All possible values of x. All possible values of horizontal along the x. And then this is f of x. All right. So the domain, can I have negative 1,000,000? Can I have negative 1 billion? Can I have a negative 1 trillion? can I have a negative Google? Yeah. And then going the other way, can I have positive a billion, positive a trillion, positive a quadrillion, positive a Google? So it's a -1 with 100 zeros after it, Jaden. That's what a negative Google is. All right. So our domain can be negative infinity to positive infinity. All right. So we can have our cake and eat it too. So because infinity is not technically a number, when we represent infinity with function notation, we have to use curved brackets. All right? So it is negative infinity to positive infinity in curved brackets. The range, on the other hand, is slightly different. All right, so the domain is every number that goes that way and every number that goes that way. However, does anything exist down here? Is there anything that exists down here? Absolutely not. So, at what point does something along the horizontal start existing? It starts at 0. And at what point, at what possible values of can I have all the way at the top? Yep, I can have, now is that infinity positive or infinity negative, Ali? So it's, and then I use a nice curly bracket around the end there. All right. Now, sometimes what you might see is you might see these symbols used instead of, for example, infinity, negative infinity to infinity. You might just see this weird R with 2 backbones. And that simply means all real numbers. If it's possible, it exists. All right? It'll be on the recording, Ali, don't worry. And how would you describe this one down here, though? Is it all real numbers, or is it only a certain set of all real numbers? Yeah, so it's all positive real numbers. So what we can do is we can represent that like that. All positive real numbers. All right. Now, where function notation also gets interesting is when you start thinking about things that may be missing from graphs. And I think some of you guys might know what I'm about to start talking about because we were just studying them. All right. So how would I do function notation when all of a sudden I now have my best friends divide by 0 error? All right. So if I have a divide by 0 error, what am I creating on my graph? What's that word called? What's that word I'm looking for? There we go. All right. f of x is equal to 1 on x. What does that graph look like? Well, hard for you guys to write in chat, but for example, we know that it looks like this, kinda, but I can't draw because I'm still learning how to use my tablet. See? All right. But what we have on, I'm going to try that again. All right. And what do I have? So I now have asymptotes. Where are my asymptotes happen to be on this equation? Yeah, they're 0 and 0. All right. So I have these asymptotes here, and I have some asymptotes here. Now, how would I represent this with function notation? Domain and range. I can have any value I like. Any value I like, except one number. All right, I can have any number I like, except one number. All right, and what we might do, so it's going to be, going back to using our previous term, all real numbers with the double backbone. However, except a number that goes in there. All right. So my domain is all real numbers except 0. And my range is going to be the same because I can have a value here, a value here, a value here. I just can't have a value that is literally on my asymptote line. All right. So that is how we can exclude particular values. All right. So, all right. Murali has given me a question. 2 root x plus 1. Fair enough question. All right. So if I draw my axes for this one. All right. Now, knowing what we know about the graph of root x, am I going to need a negative? Am I need to draw anything down here for the negatives? No, because the graph doesn't exist down here. It's also not going to exist out here. So the equation that I've been asked to draw is f of x 2 plus 1. All right. So when x is 0, so when x is 0, f of 0 is 1. So it has a point there. And then it just goes up like that. Obviously not as wobbly. But for the domain and range, however, this is where it gets interesting. The domain is from 0 and including 0 all the way off to infinity. So it's going to be our R plus. It's going to be all real numbers, but only the positive numbers. Our range, on the other hand, is going to be including 1 all the way up to positive infinity. All right, no shorthand way of writing that, unfortunately, but that's what we're going to have. All right, now what you guys are going to be asked to do in the questions in the textbook is you're going to be asked to draw equations over specific domains. All right, those specific domains are your restrictions. You have to only draw between those points that are listed for the domain. If on a SAT or a SAC you draw outside the domain, that is instant loss of marks. All right, so what you have to do is you have to be very aware that you only give us what we ask for. All right, and if we have what's called a restricted domain, that probably means the range is also going to be restricted, and you're going to be asked usually to state what the range is for the domain values that you can see. All right, so hopefully you should be able to read through 5A and 5B and have a go at 5C yourself. Any specific questions, email me. I have a lot of questions for chapter 4 that I need to record, but I haven't forgotten. All right, so I'm going to end the recording here. You guys can go off and do your work, and I will keep an eye on our emails. All right, so thank you very much, guys.